Hello, dear student friends. Dr. Bapuji Salunke Institute of Engineering and Technology, Kolhapur, welcomes you all to e-learning platform. This is Science and Humanities Department. Myself, Mr. Sudarshan Dinkar Mahadik, and the course which we are learning is Basic Science Physics. The unit which we are learning is electricity, magnetism, and semiconductors. The learning outcome for our today's lecture is apply the law of series combination of resistances in a given electrical circuits. Now, resistor. A two-terminal electronic component having specific and constant electrical resistance is called as a resistor. म्हणजे रेजिस्टन्सच्या संदर्भामध्ये आपण एका स्वतंत्र व्हिडिओमध्ये पाहिलेलं आहे. वी हॅव ऑलरेडी सीन अबाउट अ रेजिस्टन्स अँड अ रेजिस्टर इन अ डिफरंट व्हिडिओ. Now what is resistor? Once again let us look at it. A two-terminal electronic component having specific and constant electrical resistance is called as a resistor. Means resistor is an electronic component which has a fixed value of resistance. Okay, so this is the actual physical picture of a resistor. This is US resistors, means symbol in the US, United States. And internationally nowadays resistor is indicated by this symbol. Okay, so you are much familiar with the resistor. हे जनरली रेजिस्टरचं जे सिम्बॉल आहे ते आपण अशा पद्धतीने बघतो. सिम्बॉल मीन्स फिजिकली रेजिस्टर हा अशा पद्धतीनं दिसतो. आपण लॅबोरेटरीमध्ये एक्सपेरिमेंट करताना जो वापरतो रेजिस्टर तो अशा पद्धतीनं. हे रेजिस्टरचे दोन सिम्बॉल आहेत. हे इंटरनॅशनली आणि हे यू एसमध्ये वापरले जाणार. याच्याविषयी सुद्धा आपण बरेचसे फॅमिलियर आहोत. ओके, तर आजच्या आपल्या लेक्चरमध्ये आपण पाहणार आहोत की हे रेजिस्टर जर सिरीज कॉम्बिनेशनमध्ये जोडले तर काय पद्धतीनं त्यांचा इफेक्टिव्ह रेजिस्टन्स असतो. ओके, सो दॅट इज आवर क्वेश्चन टुडे. लेट अस गो. लॉ ऑफ रेजिस्टन्स इन अ सिरीज. Consider this diagram. Okay, here three resistors R1, R2 and R3 are connected in a series. See, R1, R2 and R3. These are three resistors which are connected in a series. R1, R2, R3 हे series मध्ये connect केलेले आहेत. The current I is flowing through the circuit. See, the current I is flowing through this whole closed circuit, and V is the potential difference applied. Means this V is a potential difference, means a voltage applied in the circuit. Okay, so this is a simple arrangement. Let RS is the equivalent resistance of a series combination of R1, R2 and R3. RS हा equivalent resistance आहे ह्या सिरीज कॉम्बिनेशनचा. म्हणजे काय तर हे तीनही रेजिस्टर्स म्हणजे R1, R2, R3 हे एकत्रित जोडल्यानंतर ह्या सर्किटमध्ये टोटल इफेक्टिव्ह किती रेजिस्टन्स क्रिएट झाला, हाऊ मच रेजिस्टन्स is created when these three resistors are connected in series is the value which we call as a equivalent resistance of a series combination. ओके, म्हणजे हे तीनही रेजिस्टर इथं एकत्रित अशा पद्धतीनं जोडल्यामुळं सिरीजमध्ये जोडल्यामुळं नेमका सर्किटमध्ये रेजिस्टन्सचा किती प्रभाव निर्माण झालेला आहे त्या व्हॅल्यूला आपण आर एस असं म्हणणार आहे. सिरीज कॉम्बिनेशनमुळं किती इफेक्टिव्ह ऑर इक्विव्हॅलंट रेजिस्टन्स क्रिएट झालेला आहे त्याला आपण आर एस असं म्हणणार आहे. ठीक आहे, नोट दॅट द करंट फ्लोईंग थ्रू ईच रेजिस्टर इज अ सेम. Current flowing through each resistor is the same. Means from R1 means through R1 resistor current flowing is I. Through R2 the current flowing, the value of current is I, and current I also flows through R3. Means the current flowing through each resistor is the same. Okay, now the potential difference across each resistor depends on the value of a resistor. Means what? आपण आताच पाहिलं की प्रत्येक रेजिस्टरमधून वाहणारा जो करंट आहे त्याची व्हॅल्यू सेम आहे. बट द पोटेन्शियल डिफरन्स अक्रॉस ईच रेजिस्टर इज नॉट अ सेम, बट इट डिपेंड्स ऑन द व्हॅल्यू ऑफ अ रेजिस्टर. सो V1, V2, V3 are the values of a potential differences across R1, R2, R3 respectively. मीन्स R1 या रेजिस्टरच्या अक्रॉस किती पोटेन्शियल डिफरन्स आहे V1. V2 is the potential difference across R2 and V3 is the potential difference across R3. Means the current flowing through each resistor is the same, but the potential difference or voltage across each resistor is not the same, but it is different, and the value of each potential difference is given here. Then by Ohm's law, that we all know Ohm's law is V is equal to IR, means potential difference is equal to current into resistance of a resistor. See, this is the diagram which we are considering. The potential difference across R1 is V1. The potential difference across R2 is V2. And the potential difference across R3 is V3. And the current flowing through R1, R2, R3 is the same. Current I flows through this resistor and current I flows through this resistor. So, we can write V1 is equal to IR1. We know Ohm's law, V is equal to IR. So V1 is equal to IR1. See this V1, this V1 potential difference across R1 is current I flowing through this resistor into value of a resistance. Okay. In the same way, we can write V2 is equal to IR2 for this resistor, and for V3 we can write IR3. Okay. So these are the value of a potential differences across each resistor R1, R2 and R3 respectively. The potential difference across all resistors must be equal to potential difference V applied across a circuit. Means through battery we have supplied potential difference V, total voltage V across the circuit. So the potential drop across all resistors must be equal to that V, means that potential difference which is supplied across circuit through battery. So V is equal to V1 plus V2 plus V3. Let us put the values V1, V2 and V3 that we already know the values of V1, V2 and V3. Put these values in above equation. V is equal to IR1 plus IR2 plus IR3. Now we can take common current I and this equation will turn into this. V is equal to I in bracket R1 plus R2 plus R3 bracket complete. Okay, we call it as equation number 1. Now from Ohm's law, what is Ohm's law? V is equal to IR. So for our circuit it becomes V is equal to I RS. Remember, in our first slide we have seen that R is a equivalent or effective resistance of a series combination. So V is equal to IRS. This is our equation number 2. From equation 1 and 2, IRS is equal to I in bracket R1 plus R2 plus R3 bracket complete. So from this we can conclude that RS is equal to R1 plus R2 plus R3. See, I and I is a common factor that we removed here. So what is remainder? RS is equal to R1 plus R2 plus R3. So the effective resistance of series combination of resistance RS comes out as this. So let us put it in words. RS is equal to R1 plus R2 plus R3. So law of resistance in a series, what it becomes? The equivalent resistance RS offered by two or more resistors connected in a series combination is simply the algebraic sum of resistances of individual resistors. म्हणजेच काय की एखाद्या सर्किटमध्ये सिरीजमध्ये जर का रेजिस्टर्स जोडले असतील तर त्या सर्किटचा इफेक्टिव्ह रेजिस्टन्स म्हणजे सिम्पली अल्जेब्रिक सम ऑफ, म्हणजे त्या प्रत्येक रेजिस्टरच्या रेजिस्टन्सची बेरीज, द अल्जेब्रिक सम ऑफ रेजिस्टन्स ऑफ इंडिव्हिज्युअल रेजिस्टर्स. ओके. In a series combination, the equivalent resistance is always greater than the largest resistance in the combination. In a series combination, the equivalent resistance is always greater than the largest resistance in the combination. म्हणजे कॉम्बिनेशनमध्ये जितके काही रेजिस्टर्स असतील त्यातली सर्वात मोठी व्हॅल्यू ज्या रेजिस्टरची असेल, म्हणजे रेजिस्टन्सची सर्वात मोठी व्हॅल्यू जी असेल त्याच्यापेक्षा मोठी व्हॅल्यू इक्विव्हॅलंट रेजिस्टन्सची असते. कारण इट इज ॲक्च्युली सम ऑफ these resistors. See, the series combination increases the effective resistance of the circuit. Series combinationमुळे इफेक्टिव्ह रेजिस्टन्स वाढतो, लक्षात घ्या सर्किटचा. ठीक आहे. So this is a very important point to remember. Effective resistance is the sum of individual resistances of a resistors. Okay. So this was a theory part of law of resistances in series. Let us look at some of the numerical. First numerical is 3 resistances 12 ohm, 15 ohm and 11 ohm are connected in a series. What will be the effective or equivalent resistance? इथं दिलेलं आहे पहा 12 ओहम 15 ओहम अँड 11 ओहम जे आहेत ते सिरीजमध्ये कनेक्ट केले आहेत तर त्यांचा इक्विव्हॅलंट रेजिस्टन्स किती होईल. तर R1 इज इक्वल टू 12 ओहम, R2 इज इक्वल टू 15 ओहम अँड R3 इज इक्वल टू 11 ओहम. हे आपण गिवन आहे आपल्याला. ठीक आहे. वी नो दॅट RS is equal to R1 plus R2 plus R3. ठीक. Let us put the values. RS is equal to 12 plus 15 plus 11. So our effective resistance in a series combination, that is RS, comes out as 38 ohm. Okay, simple example. Let us go towards second numerical. These kind of numericals get asked in an examination for maximum 2 marks or simply for 1 mark also. 3 resistances 32 ohm, 5 ohm and X ohm are connected in a series. What will be the value of X if effective resistance is a 40 ohm? पहा इथं तुम्हाला 3 रेजिस्टन्सेस दिले 32, 5 and X. X is unknown and they are asking you about the value of X if effective resistance in a series combination is a 40 ohm. Okay. Now which values are given? R1 32 ohm, R2 5 ohm, R3 X ohm and RS means series combination 40 ohm. We know the formula. RS is equal to R1 plus R2 plus R3. Put the values. 40 is equal to 32 plus 5 plus X. Okay. Therefore X is equal to 40 minus 30 7. X is equal to 3 means R3 is equal to 3 ohm. See, R3 comes out as a 3 ohm. Let us go towards next example. Calculate the effective or equivalent resistance from the following circuit. See the circuit. Okay. R1 is equal to 20 ohm. R2 is equal to 20 ohm. And R3 is also 20 ohm and we are asked to calculate effective resistance. We all know the formula. RS is equal to R1 plus R2 plus R3. So RS is equal to 20 plus 20 plus 20. Okay, and that comes out as a 60 ohm. So effective resistance in a series combination is 60 ohm. So these are very simple numerical examples. Thank you very much.